Today's webinar presentation is titled Rehabilitation of Degraded Hardwood Stands, Notes from Connecticut. Our presenter is Jeff Ward. Dr. Ward is Chief Scientist at the Department of Forest and Horticulture at the Connecticut Agricultural Experiment Station. He's author of over 100 papers. His research has focused on the dynamics of long-term herbaceous and tree populations, invasive species control, and forest management. He is the chair of the Yankee Division of the Society of American Forests, secretary of the Connecticut Tree Protection Examination Board, and a science advisor for the Audubon, Connecticut. He has served as chair and forest science coordinator for New England SAF and as president of the Connecticut Tree Protection Association. We're very fortunate to have him join us today. And with that, I'll go ahead and welcome Jeff.
Hey, thank you for the very nice introduction. And I heard you guys had a little bit of ice up there yesterday, just a little taste of what it's like to live in a bit of a warmer climate down here. So degraded stands, high graded stands. What we're going to cover today is first I'm going to go through some definitions of what is a degraded stand, the extent, how many of them there are and what are some of the causes. And then probably what a lot of you want to listen to today is what can you do? And I want to talk about a whole stand versus a micro stand approach. Going to talk about how the individual trees respond after you do the different treatments. And then lastly, talk about trying to get some regeneration going in some of these degraded stands. So what is a degraded stand? I tell you, the best definition I ever found, and I'm going to read it out loud and you can read along, was by Thompson et al. Just a few years ago. They said forest degradation is broadly defined as a reduction in the capacity of a forest to produce ecosystem services such as carbon storage and wood products as a result of anthropogenic environmental changes. And one concept I think it's important to realize, and they had a great figure in that paper too, is we all know, I'm assuming pretty much everyone here is a forester, that when you go out in the woods, even in an unmanaged forest, there's fluctuations over time. And when you start getting into degradation is when whatever indicator you're using, and I'll talk about that in a second, when it starts declining and it keeps on declining, it doesn't go within that natural range of variability. So that's an important concept, is realize that forests are always fluctuating. Basal area goes up, you might get a wind throw in one area or, a small blowdown, but they recover and they come back to the higher levels, as opposed to degradation where things just keep getting worse and worse. So they actually, if you are a real glutton for punishment or just a real geek like I am, you can read the entire paper, and there's an immense group of criteria and indicators for determining whether or not something is a degraded forest. The one that I'm going to focus on, all right, there we go. It's just growing stock rather than go through the whole 9 yards. In some ways, defining whether or not you've got a degraded forest out there is the same thing as trying to say, is the economy good or bad? It really depends in some part on what the measure is. But for our talk today and for my purposes, I like focusing on growing stock. And just a real quick background in what's a poorly stocked stand. A lot of what I'm going to do today is going to be tilted more towards oak, because that's what we have down here in southern New England. But the same, stocking chart, the same concept as stocking chart, also holds up there. And basically a poorly stocked stand is one, depending upon who you want to say, is either below 60 or 40% stand stocking. Wayne Clatterbuck in Tennessee, what they use for one of their books, and I'll talk about that later, defines it as less than 50 square feet of basal area of acceptable growing stock as a threshold. And another thing, I think a lot of times we can walk out there as foresters, we look at this stand and say, man, things are just not going well here. We've got to do something to bring this stand back to productivity, to bring it back to be a healthy stand. So the question is, how big of a problem is it? Well, in Connecticut, there's 200,000 acres. In southern New England, 600,000 acres. So that's 11% of the forest. If you look at the broader region, so if we include all of New England, New York, New Jersey, and Pennsylvania, 16% of the forest area has poor stocking, which is a pretty stunning figure. And another 7.5 million acres away, 7.5 million acres are one harvest away from becoming poorly stocked. So it's not only a big problem, it could potentially become a much, much bigger problem. So what are the causes of having, poorly stocked stands, degraded stands? Well, some of them are just some natural conditions. Like if you have, a high water table, you're never going to have a highly stocked stand on those. And the same thing with skeletal soils, or as they say in England, skeletal soils. You just have these thin soils that are, close to the bedrock. You're never going to have, high stocking on those stands. Sometimes you can have heavy duff. That can be another cause. Sometimes more natural. Well, we can see down here sometimes, this might look like it's not a bad stand. There's, in fact, I think there was less than 5 feet. I think there's only 2 feet of square feet of basal area of acceptable growing stock in the stand. It was all junky red maple and junky ash. Was all punky and full of holes and rotting, and every plant you can see there, it's not a tree, is an invasive species. And invasive species can be a big cause for having poorly stocked stands. This is one which I think might be in the southern tip of Vermont, is Japanese stiltgrass. Aesthetically it looks kind of pretty, but there's not a wildflower growing in that stand. There's no tree regeneration, so it's a combination of this invasive grass, it's an annual grass, and heavy deer browse. I mean, it's just stunning to see the lack of shrubs and tree regeneration. And there's a number of things. Down south, they have problems with kudzu. In Ireland, they have the problem, sort of beautiful problem, of rhododendrons. And you get up into your neck of the woods into Vermont, and buckthorn certainly can be a cause for poor regeneration, leading to poorly stocked stands and degraded stands. There's other problems we currently have, and some are going to be coming down the pike. One of them is gypsy moth, which we've had a few bad years here. Here's a picture of it back in 2016, defoliation. We actually recommended that they went into a salvage harvest, hoping that some of these trees could actually resprout if you cut them down when they still had root reserves. Well, the Parks Department decided not to cut them down, and a year later, 95% of the oaks are dead. Now they've got upwards of 10,000 acres of just dead trees. And when I mean acres of dead trees, 95% of the trees are dead. And imagine the problem we'd have if Asian longhorn beetle ever escaped and got out into the woods and started hitting all of our maples. To see forests like this is just incredibly discouraging. What do you do? One problem I do know that is going up your way, and we're certainly dealing with it down here now, is emerald ash borer. Every dead tree you saw there had been alive the year before. There had been an infestation, and it's weird with emerald ash borer. A lot of times you won't see it, and the next year the trees will be dead. And don't think cold temperatures are going to save you. In Michigan, they got to 44 below, and it didn't kill the emerald ash borer. Not so much of a problem here in New England, but fire can sometimes cause widespread damage in stands with low stocking. And the big problem we have here further south, and as things warm up, deer densities are probably going to increase further north, are deer densities, especially when they're combined with invasive species. Look in the stand on the top left. That's a 15-year-old shelterwood. The only thing you see growing underneath there is Japanese stiltgrass as a grass and a couple of invasive shrub species. Right next to it's a 15-year-old clear cut. Some of the trees you see sticking up, some trees have gotten up, but they're all black birch or hopthorn beam, Australia, that are sticking up. 15-year-old clear cut should just be this dense thicket. And even below with a 17-year-old diameter limit cut, I had a false colored a little bit so you can see it. You can see through there 100 yards through the woods just because of deer. So we're not getting regeneration back in these stands. But far and away, the biggest cause of degraded stands is high grading, and it's for the money. And it's one of the problems we certainly have, that people will go in there, they'll cut all the trees that are worth some money and leave junk behind with no thought for regeneration. And the big reason for this is Gary Miller pointed this out in West Virginia, and we actually did a stand analysis here in Connecticut in 6 stands. And we found that in Connecticut, 10 to 20 trees per acre account for 50% of that stand's value. And that's going to be true anywhere where you're not looking at biomass. If you're being paid a premium for grade sugar maple, for grade yellow birch, as opposed to what just goes into pulp, those few trees per acre account for most of the stand's value. And 90% of the stand's value is, attributed to about 50 trees per acre. So only 50 trees per acre account for a majority of the stand's value. So there's a real economic incentive just to go out there and cut those trees with money, which is something I think we all know. And there's been a lot of early warning signs about diameter limit cutting. Papers going back into the 1950s, including Bloom and Philippe in New Hampshire back in '63 and Hart in Maine in '64. But there's been papers over the years saying, hey, there's some real problems with it. People found poor stand growth, poor quality residuals, increased amount of red maple and loss of oak. Actually, is my first work I worked on. Low quality, slow growing residuals, and an increased proportion of residual trees which are calls are of lower grade. But I think most of the attention, where really gathered attention, was when Ralph Nyland back in 1992 in the Journal of Forestry wrote a great article. I'm not certain how much it's been cited, but I know a lot of us, it really got us thinking about what's going on here. The fact that our forests grew up from all the exploitation and cutting and farm abandonment back in the early 1900s. But by the 1980s and 90s, there was just an awful lot of high grading going on out there. And Ralph really wrote a great paper that brought attention to this. So how can this happen? Well, one thing is people talk about selection harvest, and as foresters, we know what a selection harvest is. But sometimes people who, are logging or have to make payments will go up to the landowners and say, we're going to do a selection harvest where we're just going to be cutting those largest trees and we're going to let the next generation to grow in. And a selection harvest can be entirely appropriated for stands of the valuable species that are shade tolerant. So if you have sugar maple, or if you're lucky to be in an area where you can actually grow beech that doesn't have beech bark disease, and put in some small gaps so you can get in some yellow birch, you can definitely do selection harvest. The problem is selection harvest, all too often, they slide into high grading because people have to make payments. Loggers have to make payments on their iron. Landowners, need some money. And a lot of times there's really no tending of the smaller size classes to try to get that diameter distribution and that species distribution. So how does this happen? Well, you can start with a stand, and you can say you're going to do single tree selection, which is, trying to mark to hit that Q curve. But what can happen is you need a little more money, so you go into a diameter limit harvest, saying, well, we're just going to take the biggest trees and the younger ones will grow up. But then that slides into high grading, where only small trees and trees with no economic value, the calls are left. And that's when you get into a poorly stocked or degraded stand. If you look at forests, which tend to have mid-tolerant and intolerance on top, they usually developed as a stratified forest. And in those forests, you should only be doing tending cuts or thinnings and regeneration cuts. Let me skip over that one. Forgot to take it out. So how do these forests grow? Well, over time, the mid-tolerant species gradually grow faster and faster than the shade intolerant subcanopy, which develops underneath. So what will happen on these forests is what you should do is do a thinning out there for your intermediate or your tending cuts. But those can also lapse into a diameter limit cut because there's not quite enough volume out there to make it economically feasible. The landowner wants a little bit more money. And if they get a little bit greedy, it can go right into high grading just as you can with the selection cut sliding into high grading. And after high grading again, what you're left with is a stand of small trees, often of less valuable species. You're left with trees with lower quality and high percentage of call. It's just a real challenge to manage it. Well, one of the things my predecessor did back in the early 1980s, George Stevens, is he put in a cutting method study where we're going to directly look at this. And we've got these in at 3 locations down here in Connecticut. And he put in a commercial clear cut, which is a high grade, where only trees which were 11 inches in diameter and greater were harvested, and only merchantable trees. They didn't cut any call trees. They also did a diameter limit cut where oak, sugar maple, and ash with an 18-inch diameter, and other species at a 14-inch diameter were harvested. But one of the important things there is they removed all call trees. And I wish I could find the paper, but I believe I read one place where Bill Leake had mentioned that if you're going to do a diameter limit cut, the important thing to do is to cut out all the call trees. So it's one of the things they did there. We also looked at something which is multi-age crop tree management. And the idea there is that you pick or have 50 to 60 crop trees growing per acre. Remember, 50 to 60 trees per acre accounts for 90% of that stand's value. And what you do then is you go about every cutting cycle, and here's roughly 20 years, and you cut 1/5 of those crop trees per acre. So you're cutting about 10 crop trees per acre. And if you recall that earlier slide I showed, that's about 50% of that stand's value. And you pick some new crop trees to try to push those to grow out of the new poles. And then you cut all other poles. And I probably should have put a slide up here. I don't have one, but it's interesting. The stand after harvest looks a lot like a cross between a shelter wood and a city park, where you've got tree diameters of tree sizes across the spectrum, from pole trees up to large saw timber across the stand. And then we also had in a shelter wood, which in some ways is going to serve as our surrogate for putting in crop tree management. And the shelter woods removed half the basal area and half the upper canopy to let light come in. Just a little bit of a diagram here to show you what it looks like we're talking about, so I can get a drink of water. Now, what's interesting on this study is we followed these for the first 16 years for the first cutting cycle. We cut it short a little bit. And in the unmanaged forest, where we did the diameter limit, where we cut the call trees, but like I said, the oaks were 16 to 18 inch. The other ones were 14 inch limiting diameter. In a shelter wood, in a multi-age crop tree management, board foot volume growth was not significantly different between those treatments. There was a slight decrease in the amount of oak that we were growing, but overall we were maintaining board foot volume growth for 16 years. It's something I think a lot of people don't appreciate. When you put in a shelter wood right at about 50 square feet basal area, you maintain the same board foot volume growth that you do in an unmanaged stand. But look in the far right, look where it says high grade, where they cut only merchantable material down to 11 inches. And I said the call trees weren't cut. Board foot volume growth was drastically decreased. Well, then we did a second cutting cycle. We went through. Actually, next year we're going to be doing our third cutting cycle on this. And here's the scary thing. Even if you put in a diameter limit cut, where you're cutting out the call trees, after the second cutting cycle, the residual stand of a diameter limit cut after 2 and a high grade is identical. We've lost most of our valuable oaks. When I say maple in there, it's red maple. It's not sugar maple in these stands. Birch down here is black birch. And most of the other on there is beech. And unfortunately, beech bark disease is an issue down here. So even if you are putting in a diameter limit cut and you're cutting out the unmerchantable stems, the call stems, after a second cutting cycle, you've really changed the way that forest looks to the bad. So the question is, what can you do about all this? Well, you want to look at rehabilitating poorly stocked stands. And I want to show you this stand here is truly the stand from hell we have down here. It's an island that had 750 deer per square mile before they went out and cut them all, shot them all. 16 acres with 17 or 18 deer on it. Every tree you see there is a lanthus. So there was, the entire stand was a lanthus except for a 5-acre piece of Norway maple. I think we found a couple sassafras, one cherry, and a couple red maple on the entire island. All the vines are Oriental bittersweet. All the shrubs are Japanese barberry, multiflora rose, and all the ground cover, most of it was Veronica officialis, which is a non-native species. There wasn't stiltgrass on there at the time, there is now. So the question is, what the heck do you do? Obviously, this is an extreme case. Well, just in case there's some non-foresters out there, I just want to mention basal area. You know, it's a cross-sectional area of all trees of 4.5 feet added together. And because I'm going to be talking about basal area, it's nice is that within the ranges we usually look at, biomass is approximately linear with basal area. So you're talking, when you talk basal area, we're also talking about increases in stand biomass. And just one other concept that you know, sometimes people forget about, or for the non-foresters, is UGS versus AGS. UGS are unacceptable growing stock. They can be trees with a poor form, with severe crook, sweep, or low fork. They're poor health, you know, they're dead or dying trees. A high percentage of call, so they've got a lot of decay inside of them. Or they're undesirable species, and that's going to depend on local markets. An acceptable growing stock is everything that's not an UG. So we're going to talk about UGS and AGS a little bit on some of these. And just a reminder from what we talked about earlier, what's a poorly stocked stand? If it's below 60 or 40% stocking, it depends upon what you want to call it. And or if you want to say, you know, 50 square feet basal area. It's going to depend upon where you're at and what you want to define. Now you can do a stand approach. I mean, obviously these are way too small to be stands, but it's just for an illustration. If you look at all these, if we look at the orange one, let's imagine, you know, it's at least 10, 20 acres in area. You know, even just looking at it, you can tell that that stand has some area, has some problems rather, just from looking at the texture of it. And there are a number of guidelines out there and handbooks on how to deal with it, but they talk about doing everything at the stand level. And there's some pretty complicated rules, but it's the idea of treating that entire stand, let me go back, treating that entire stand within the orange as if it's all identical. Well, here's the thing. Most of us have had an opportunity to wander through high-graded or poorly stocked stands, you know, degraded stands. They often and usually have patchy structure. You can have some areas where you've got gaps with some seedlings coming in. You can have other areas where you've got pole trees, some that are potential candidate trees to grow into the future. Some of them are just so ugly you want to cut them down right now. And some areas where you might have some saw timber that was left because maybe the market wasn't there, or maybe it's junky saw timber that has a lot of call. So you're looking at very different stand structures. And I don't know whether or not you want to apply, you know, one treatment to the entire stand. There's also the other thing is that pre-prescription inventories cost money. You know, foresters we're not going to go out there and walk around and do the inventory unless you get paid. Writing up a prescription plan costs money, and poorly stocked stands have very low value. And just to give you an example, this is from where we did a rehabilitation study I'll talk about in a little bit later, is we put in 10th acre stands out there and we measured UGS, unacceptable growing stock, versus AGS, acceptable growing stock. And you can see within individual stands, it can be all over the place. Some stands, you have almost no acceptable growing stock, like the upper left, the you actually pronounce that ER, so it's airlick preserve. And then you can have other stands like the lower right, or actually both the lower ones, where maybe half the stands actually have acceptable growing stock. But if you look at the lower right in the Rebecca one, UGSs have a tremendous amount of unacceptable growing stock, which is competing and slowing the growth of the acceptable growing stock you have out there. So what's the alternative? Well, again, let's look at the that area circled by orange in the bottom center. Zoom in on it a little bit, and imagine you were to get out there with a harvester, and you're going to look at a micro stand approach. And let's look at the radius that a harvester can do and divide the stand into different types. So you could have some areas of the stand where you actually have, some saw timber of decent quality. You have other areas of the stand which are a complete mess where there's nothing within the harvester's reach for it can have. And other areas which are sort of the mix of the conditions or might have sapling stands. Just imagine the stands that you walk in, the degraded stands, the high-graded stands, and you can see in your mind's eye that they're always this mixture. And the folks up in Quebec, Lussier and Meek, have actually written about this, and they developed an approach that they're using up in Quebec, because I think everyone in this hemisphere certainly has the same problem, at least in the hardwood stands, that we have to deal with. And what they did is they developed this system of training the loggers going out there with mechanized equipment to recognize 4 different stand conditions, and then to let the loggers decide what they were going to do. And they found out with training and going out there and doing feedback that the loggers 90% of the times would do the same treatment that the foresters would do. So it's always go out there, and trust but verify and walk out. But it's a way so you didn't have to go out there and do a prescription inventory. You didn't have to go out there and write up a management plan, a prescription plan. But the logger could go out there and just implement the activity. So the management plan, prescription plan said, here's what your choices are when you go out there. So to go through what they did up in Quebec really quick, is they said, first, is there a multi-storied maple stand? If there was, do a partial regeneration cut, but let some of the larger maples grow. If you didn't have a multi-storied maple stand, and they're talking sugar maple up there, are the saplings abundant? If they were, cut down all the poles and saw timber, let those maple saplings continue to grow up. You're going to have, some yellow birch is going to seed in. Used to be we get some ash coming in, but not so much anymore. If you didn't have that, if you had a closed canopy, if you did, you could do a shelterwood cut and do some patch scarification so you could get in those light-seeded species like aspen, like yellow birch. And if you didn't have it, a closed canopy, well, then you're going to want to cut the brush and do patch scarification to try to get the regeneration coming back in. So again, it's that whole idea that we've got within a high-graded stand, we've got all these different conditions. And rather than write a prescription which is going to suit the entire stand, why not train the logger and work with the logger and let them make the decisions out there following your guidelines, realizing that now we're going to have this uneven age forest, but it's almost like just doing, in fact, it is basically doing a group treatment, a small patch treatments throughout the forest. So you're going to end up with this uneven age stand structure. I mean, the other alternative in a lot of cases would just be to clear cut the whole bloody thing, but hopefully. So we wanted to see how this would work, in hardwoods further south in Quebec. So we put together a project, and we had, a number of land trust and private groups and the town and the local DEEP down here working with us on the project. And we put in sites throughout the state to try to look this on high-graded stands. And these stands actually had been high-graded. What's not uncommon down here, unfortunately, is before someone gives a donation to a land trust, to go out there, the stand will be high-graded, then the land is donated. In one case, the stand, no one had paid any taxes on it for 90 years. It was over 100 acres. So the town went in and high graded the stand to get the money for the taxes and then donated it to a land trust. In another case, it was a forest owner who had been taking care of it, got sick for a little bit. A relative took over, unfortunately hired an unscrupulous logger who came in and high graded the stand. You know, there's a lot of different ways that these high graded stands can develop, as I said before. So what we did is we looked at, 20 by 20 meter plots. It's about 1/10 of an acre. 20 meters is almost exactly one chain by one chain. And this approximates a 30-foot radius that, a lot of mechanized harvesters can handle. Although I should say we did cut everything by hand. And if you've never seen who I am, there I am pretending to be a logger. So what we did is we came up with a number of different prescriptions and went out there. So what we looked at is, are there at least 5 quality pole-spaced trees per acre? If there were, cut all the larger competition, those 5 to 10 target poles. That would give us 50 to 100 potential crop trees when the stand was mature. If we didn't have at least 5 quality pole trees, were there at least 10 saplings per acre? And if there were at least 10 saplings, we cut all the pole trees and all the call trees. If we didn't have that, were there 2 to 4 well-spaced quality pole trees? And if there was, we would cut all the poles and calls except for the target ones, hoping to develop that into a 2-age stand, a 2-age plot. If we didn't have any of that, we had a regeneration plot, what we're going to try to. We cut all the poles and saplings. If we didn't have any advanced regeneration, then after we cut it, all the poles and calls, we would actually do planting out there. So this idea of looking at the micro stand, looking at a 10th acre, what can we convert that stand into so we're going to have some quality trees growing on there in the future? Just so you some of them looked like, this is a high intensity 2-age plot where we went out there and actually planted white pine underneath to try to get a conifer component growing. This is a low intensity pole timber plot where we released 5 to 10 quality pole trees per acre to give them room to grow. Actually, those yellow birch are growing like gangbusters now. This is one you might remember at the very beginning. I told you it was a stand with just 2 to 5 square feet of acceptable growing stock per acre, and because it was all crappy red maple and ash was dying and it was full of invasives. So we just clear cut the whole thing and did a planting on it after going through and actually the season before we did the harvest, we went out there and sprayed for all the invasives. This had been 6-foot high mixture of barberry, multiflora, rose, and bittersweet. So we've talked about the whole stand versus micro stand. Let's see how the trees actually grow and what happens after we do this. Well, if we look at the stand level, beforehand on these stands, we had roughly 35 to 40 square feet of unacceptable growing stock per acre and only about 25 square feet of acceptable growing stock per acre. I've clearly, degraded stands. After we went through and did the treatment, we removed most of the unacceptable growing stock. We did leave some unacceptable growing stock. It was, in some cases, they were white pine or cherry trees, which had poor form. Can everyone hear me? I'm saying I might have network connection difficulties. Catherine, are you there?
Yes, Jeff, you're coming across loud and clear.
Oh, okay, good. I just had a red warning came up over here. Sometimes we leave unacceptable growing stock either as a seed source or for wildlife trees out there. But generally speaking, we really flip the ratio of unacceptable growing stock to acceptable growing stock. And if we look at the stand composition, you can see, dramatically, like I said before, it used to be mostly unacceptable growing stock. And then after we did the treatment, we had mostly acceptable growing stock. And it was more in the species that we were trying to promote. Down here it'd be oak and cherry, but certainly, and hickory, I should say. If we got cherry or sugar maple, we are fine. I should say we started this study up a year before emerald ash borer came into the region, which is unfortunate because we had been promoting ash. So what can we look at for the growth rates of all these trees for the acceptable growing stock that we left? And these are for pole and sawtimber diameter growth. If you look at each one, so we have maple on the left in the blue, oak in the center in the red, and hickory on the left in the yellow. And we go from no, which is no release of the trees, to those trees that were partially released by doing this treatment, to trees that were fully released doing the treatment. And we can see that going in there and releasing this acceptable growing stock, like for maple, we increased it from about 0.4 of an inch growing beforehand in a 4-year period, so about 1/10 per year, more than doubled its diameter growth by giving those maple trees full release. Those trees were able to respond and are now growing, biomass much faster. The same with the oak, basically doubled their growth rates. Hickories, not so much. But here's what I think is one of the really cool things about doing all this. When we went, if we look at on the, let's look at the right first. And we've got acceptable growing stock, and that's 4-year basal area growth per acre. And then we have unacceptable growing stock. And you can see unacceptable growing stock on areas that weren't treated, the controls, was more than double that of acceptable growing stock. But after the treatment, for the 4 years after treatment, if we look at the two on the left, it says treated, acceptable growing stock now is actually, we have more acceptable growing stock is increasing more, or is growing faster than the unacceptable growing stock. We've really flipped it. Now these stands, the majority of what they're growing is acceptable growing stock, which I think is great news. And if we look at, how are the saplings that when we went through, remember I said, some of these stands, if we had 10 saplings per acre, we would release them. Well, you look at the oak saplings that weren't released, very little growth. Over 4 years, those things grew about 0.4 of an inch in diameter, very little. We didn't get height growth, unfortunately, on here. But if we release those trees, and I won't go into the difference between high and low, we basically doubled the diameter growth of those oak saplings. We really increased how they were going to do. One of the unfortunate things is you really would want to come back and if you're trying to get oak and do a second release, because the birch and the pine, and the pine is white pine, eastern white pine, and the birch is black birch, we're growing much, much faster than the oaks. Now up in your neck of the woods, having a lot of white pine do real well and having a lot of yellow birch do real well is probably going to be a great thing. Down here, though, we're trying to focus a little bit more on oak. One of the things we found from earlier work, and this is probably more for the folks in southern Vermont, is that many, if not most, codominant intermediate oak saplings will not stay in the upper canopy as time goes on. If you look at the diorama, it's just trying to show it there. Concept part. And if you look at the bottom, you can actually look at the numbers. If you go into a stand right at a canopy closure, 10 to 15 years, 71% of the dominant oaks are going to remain in the upper canopy, but only 27% of the codominant oaks are, and only 6% of intermediate oaks. So if you don't release codominant oaks, 3/4 of those are going to fall out. But if you go out there and do pre-commercial crop tree release, and we've got a couple of papers in Forest Ecology and Management and a Canadian Journal. If you go out there and you just give those oaks, full canopy release just once, you can increase the percentage of codominant, the originally codominant trees that are going to stay in the upper canopy from 27 to 56%. You can double the proportion of those trees that are going to stay in the upper canopy.
Hey, Jeff, Kate, just a quick clarifying question that's coming
Sure.
from Russell. When you say 10 saplings per acre or 2 poles per acre, do you really mean a 10th acre plot?
Thank you. A 10th acre plot. So it's going to be like 100 per acre. That's a great thing, and thank you for pointing that out. So were we releasing 10 per 10th acre plot?
Great, thanks for clarifying.
Sure. And the last thing is on regeneration. It looks like I'm actually running a little bit longer than I thought it was, so I'm going to speed it up a little bit. Is Ralph Nyland? I tell you, we're very fortunate to have him here in the Northeast. And he has given his recent talks, what he's talking about with regeneration. This is what he says, 50 years distilled. Shoot the deer, poison the beech, and manage the light. And he's old and retired, so he's allowed to be a little more brusque. I put it a little bit softer. Limit deer browse damage, control competition, and let the sun shine in to get the regeneration in these degraded stands. Now you can do hunting, but the problem is you need to really get regeneration going to reduce deer density to 12 deer per square mile or lower. There's quite a number of studies out there that recreational hunting is not going to reduce deer densities much below 20 deer per square mile. That's at the point when hunters just pretty much give up. There's too much time to actually be able to get a deer. And here can be the problem. This is a stand down here where there's a high deer density. Those sugar maples underneath there, we dug them up, half a dozen of them up. We dissected them with a razor and looked at the microscope. That's 17-year-old sugar maple reproduction. Pretty depressing. And damage isn't just limited to deer. We also have moose can do a real problem in some areas, especially again with oak. They'll actually straddle oak saplings 2-3 inches in diameter and eat the tops out. Some places there are some hog populations now in I believe New Hampshire and upstate New York. They can do a damage. Voles can do a damage. Porcupines can do a damage. We actually looked at deer, and we didn't look at deer density per se. We just looked at hunted versus unhunted areas and did regeneration counts. A little bit complicated, so I'll explain this. So we looked at areas that it had a shelter wood, and then it had the final overstory removal. And on top are areas that weren't hunted, and on the bottom were stands that were hunted. And so we put in these regeneration plots, 1 every 2 acres, at least 15 for every stand. And so let's look in the top where it says not hunted. And so the upper left, the like 10 and 11 o'clock positions where it's green and blue, those are stands that have 120 to 160 oaks per acre, because that's what we were trying to look at. But let's imagine that our target goal is 60 oaks per acre in a competitive position. If you look at the not hunted areas, so that 10, 11 o'clock, there's about 15% of those stands actually had, at least 60 oaks per acre. Where if we look down below it in the hunted ones, over 50% of those stands had at least 60 oaks per acre. So we didn't look at deer density because some of these stands were 10, 11 years old, but there's a real difference in just hunting and not hunting, showing what deer will happen. If we look in the shelter wood when we're doing the prep cut, in areas, shelter woods that were not hunted, we had no stands that had at least 60 oaks per acre that were in a competitive position or were competitive oaks. In fact, the best that we had is we had some stands had 20 oaks per acre. Or if we look in the shelter woods where we had hunting, and even with a goal of 60 oaks per acre, we had 2/3 of those stands had acceptable oak regeneration. And I should say in most of the areas that weren't hunting, the regeneration we had was primarily black birch and beech. And some of them had red maple, not a good mix. I think anyone who's ever planted trees in an area with deer browse has seen this. On the left is an 11-year-old white pine, which has been not protected from deer browsing. To me, it's amazing a thing has survived that long. And on the right, even though these Vexlar, these mesh tubes aren't the world's greatest, 6 years old, we've now got them up above browse height. Real difference. So what can you do? You can do the Pennsylvania solution where they actually fence in hundreds of acres of every year. But they had big bucks, and actually one nice thing in Pennsylvania, they're required to invest, I believe it's 5%, it might be 2%, of all harvest proceeds have to go towards regeneration practices on state lands. But they have to be at least 8 feet high, they're expensive to put in, and they're expensive to maintain. You know, the other alternative, because recreational hunting, like I showed before, you know, does help. But to really get the deer herd down, you're going to have to go out there and do a sharpshooter. And what's interesting, for the cost to $8,000, what the cost is for 25 acres, you could have a sharpshooter basically control deer on 640 acres. So getting to Bill Niles' thing where he talked about, you know, shoot the deer, poison the beech. Well, it's more than beech. You know, there's a lot of non-native interfering species out there. I said, you know, we have stiltgrass and mile a minute and bittersweet. You guys have buckthorn. When it gets warm, you'll get our problems. But also some of the natives can be interfering species, especially in areas where there's a lot of deer. Hay-scented fern can certainly be a big one. Beech can be a big one. Occasionally seen hobblebush. So what can you do where you have a lot of interfering species? Some areas you might be able to go out there and mist blow them. We've actually done it, it works. You know, do spot treatments. One nice thing with buckthorn is if you are using an oil on the stem, you only need to spray 1 or 2 stems in a clump. If you have a lot of time and you just like having fun, you can use a propane torch. So I think this is about the last graph I'm going to show you is on the is from a study where we looked at both controlling invasives and controlling deer. So if you look at the one on the left where it says outside exclosure, if you look at the purple diamonds going on there, you can see roughly there were 100 stems per acre that were 3 feet high or taller. They were almost all beech. I should notice that the y-axis actually has stems per acre. If an area where we mowed down all the invasives and then went out there with flamethrowers twice to control them, after 9 years, we're finally starting to get some numbers of trees that are at least 3 feet high, but they're still being hammered by the deer. And most of them were either beech or they were black birch. Well, inside the exclosure, where we didn't have any deer browse, the regeneration of trees at least 3 feet high went up really quickly where we controlled invasives. That would be the orange squares and the green circles. It's interesting that if you look at on the right-hand one, the purple diamonds, just preventing deer browse if you have a lot of invasives wasn't enough to get the regeneration going. You also had to control invasives. You might ask, well, I see that the number of larger regenerations going down after 7 years. Well, that's because a lot of these were actually moving into the 3 to 6 foot height class. So the bottom line is, if you've got an area where you've got a deer problem and you've got an invasive problem, you've got to not only treat the invasives, you've also got to get the deer browse density done. If you don't lower the deer browse density, you're basically wasting your time. So if we look over here, like I said, you know, we controlled invasives, but we didn't control deer. We still have very low regeneration numbers, and nobody over 6 feet high. So the last one for Ralph Nyland: shoot the deer, poison the beech, manage the light. This is a little bit lighter one. For oaks and a lot of mid-tolerance, when you're trying to get the regeneration established, you want that 30% light levels. You let in more light, you're going to get in birch, and down here it's tulip poplar. Up your way, it's going to be more aspen. You let in less than that, you're going to get in more sugar maple and American beech. And the one thing I should point out again, I just want to hammer this point home. I know it's not a problem yet up there, but as things warm up, it probably will be, are going to be the problem with deer when you've got large deer herds. So we did a study where we actually put big cages around stumps to find out the impact of deer on stump resprouts. And one of the things is oaks are getting older, we're getting fewer and fewer sprouts. Here's what it looks like 2 years later. See the small one that my Tech JP is pointing out on the left? These are the same size stumps, and the deer hammering it. That stump actually died a couple years later. Where the stump in the background is surrounded by a cage, in 2 years, it's already above deer browse height. And that tree right now is about 20 feet high, 20, 25 feet high 6 years later. It's pretty amazing just the impact that deer have. So what we've covered today are some definitions about the extent and causes, and that throughout New England, New York, New Jersey, and Pennsylvania, it's roughly 16% of the area has degraded stands with low stocking. We talked about you can do a whole stand approach. I would suggest, especially if you're talking with a small landowner who's going to be cutting his own trees, or if it's someone larger parcels where they're using mechanized harvesters, to consider a micro stand approach where you've got 3-4 options for the harvester to go out there and do. Residual stems do respond quite well to the release. And for regeneration, you've got to control the interfering species, reduce deer browse damage, and let in the light. So with that, I think Kate said that she was going to be able to either ask me or type in some questions.
Yeah, thanks so much, Jeff. Thanks for the great presentation. And just a reminder to folks that we do have a few minutes left for some questions. So if you have any questions, please go ahead and type them into the question box in the GoToWebinar panel. Jeff, we did have a kind of follow-up question from Chip, and I think you hit on this a little bit, but I think it's worth revisiting. As you know, treating American beech can be really expensive if you're using herbicides. So he's wondering, what are some suggestions for other approaches? You mentioned quickly the less than 30% light, but any other thoughts on managing?
Well, the less than 30% light is going to help promote beech growth. I tell you, the thing with beech is once it's out there, if you've regenerated the stand, you could go out there and just cut some of them waist high. If it's a stand you're not going to go back into to release the other regeneration, just to get them on top of the beech and realize that the beech are going to be underneath there. One thing that Ralph Nyland said they did, it works, but I would not want to be a logger going back in, is if you cut a beech below, this is before you do your harvest, below the last branch with live leaves, the beech will not root sucker. The thing is, then you're left with a bunch of punchy sticks out there. So my only suggestion is go back out there, 5, no more than 10 years after you have a harvest, and wherever you've got a quality, or potential quality sugar maple or yellow birch or oak or whatever you want, it has a lot of competition from the beech. Either bring a small chainsaw or a machete or a hatchet and chop that beech down, even a waist high, just break it down so the other tree is now on top. And the beech don't seem, once you do that, they don't grow as much, just from what we've tried for grins and giggles down here.
Great. Interesting. Okay. Jeff, there's another question from Michael, and this sort of puts you on the spot, but he was wondering if the presentation would be available as a PDF. I don't know if are you to make this presentation available. And then just a reminder, I guess, to participants as well, that the webinar today has been recorded, and so you'll have access to the recorded version of this webinar on the webinar series website.
If he emails me, I can send him one, but I'm going to have to put 4 slides on a page, because even compressing pictures, it's 26 megs, which is bigger than our system likes sending out.
Great. Jeff, would you mind sharing your email address with participants? That way if they
It should be on the screen right now, isn't it?
I have the question box open, so there it is. Yes.
Oh.
So there it is on the screen, folks. So you can go ahead and email him directly, Michael. Well, I'll go ahead and give folks another minute to submit any questions that they have. And in the meantime, Jeff, just again, want to thank you so much for a very informative presentation today. And I was going to share too with participants the announcement that our next webinar has been scheduled for March 20th. And we'll be hearing from Adam Sherman with the Biomass Energy Research Center on Vermont wood fuel supplies study. So just a heads up that the next webinar will be scheduled for March 20th. And with that, Jeff, I'm not seeing any other questions in the question box at this time. But we really appreciate you taking the time to share this research and all of your experience dealing with degraded hardwood stands. Yeah. Any other last comments from you?
No, I just say if anyone has any questions and wants to email me, certainly go ahead. You can try phone calling, but today's turning into a nice day and tomorrow's going to be nice. So I tend to spend a lot of time out in the field. So email is always best. And I really appreciate the opportunity to speak.
Great. Well, thank you so much. And a lot of comments that are coming in, just again saying thank you for such a great presentation. Great presentation from that Dave says thank you again. There's a note here from Terry. It seems to me that we need to focus some on our efforts on training loggers and making landowners aware of good forestry as well.
Well, I think they're absolutely right there. I think most loggers like to look at a stand afterwards. It's interesting when we put in the high grading study that the logger was actually, they had a young kid who's probably 28 years old, was coming out there and asking us what the hell we were doing. He didn't know it was part of the study. And he wondered why we were high grading the stand and making it look so bad.
Huh.
I think most of them want to see good work. You know, there is that tension on bringing in enough money to pay for equipment and pay wages.
Yeah.
But I'm absolutely convinced that 90% of the loggers want to see a nice forest because they realize that's some places they might be able to come back to 20 years later.
Yeah, really interesting. There's a long-term commitment there. And Rick points out too, you know, there's continued work that needs to be done in training foresters as well. So again, we just really appreciate your time today, Jeff, and sharing this this information with us. And hopefully we got a start of getting everybody on the same page and thinking about these issues.
Okay. Take care, and I hope everyone has a great day.
Great. Thanks again, Jeff. And again, everybody, thanks for participating today, and have a good day out in the woods. All right. Thanks again, everybody. So thanks again, Jeff, for your time today. And if you want to go ahead, you can just, I'm going to wait for folks to go ahead and leave the webinar. But if you want to go ahead and just sign out, you're welcome to do that. And again, I appreciate you sharing all this information.
I was going to ask one favor. If you could send me a summary of, because you said you had a questionnaire.
Yes. Yeah, we have a survey that that they'll get at the end of the webinar. Yeah.
Because you probably have not only I don't know if you ask acres and things like that.
You know, I don't actually. Yeah, I'm sorry. So as I said, I don't actually. I don't have that information specific to this webinar. We do have information, you know, just a profile of our audience and how many acres they manage. What specifically are you looking for?
Well, it's one of the things we have to do, and you probably have to too, is federal reports at the end of the year.
Yep.
For I was trying to think, because Pete Smallage Beck would ask those questions. So you want to know is how many people you were reaching, how many acres they were managing. I'm blanking out right now what they call it for on reports, but the feds just want to know that in fact you are doing outreach.
Yeah, let me think about that, Jeff. I may have to do a follow-up survey with folks on the webinar today to get acreage. It's funny, the funding for this webinar series originally started with a grant from the Forest Service, but that grant has been closed out. So we've just been doing this series, as part of our partnership. So it's one of the rare cases where I'm actually not doing federal reporting on this webinar series at this stage, but it's definitely good information to have, and I'll think about how to incorporate that into the survey in the future. We did an impact study about a year ago. So I have some data as to kind of the cumulative amount of acreage that participants manage. But if that information would be helpful to you, I can certainly do a follow-up survey and ask folks to share that information.
Oh, appreciate it.
Yeah.
Well, have yourself a good day. I don't know about up there, but we got blue skies down here now. So
yeah, it looks like the sun's shining here too. So thanks, Jeff, again for your time, and I'll follow up with you by email with the survey results and what I get back for that question around the acreage.
Okay, sounds good. Take care.
All right, you too. Bye.
Bye.
All right, folks, just a reminder, the webinar is now done. So if you want to go ahead and sign out of GoToWebinar, you should receive a survey after you leave the webinar to complete your request for continuing education credits and to provide feedback on the webinar today. So go ahead and leave the webinar, and you should receive a link or pop-up from GoToWebinar to complete that survey. Again, if you don't have time to complete it today, you can also complete the survey that'll be emailed out to you separately or after the webinar today from GoToWebinar. Thanks again for your participation.